In today's video, we are going to explore the concept of pressure. Pressure can be defined as the amount of force applied per unit area, and we quantify it using the formula that states pressure, which is measured in Pascals, is equal to force divided by area. For instance, if you strike a nail using a hammer, you are applying a force on the surface area of the nail head, and this interaction results in a specific pressure being exerted on the nail. To illustrate with an example, if a force of 800 newtons is applied and the area of the nail head is 0.0001 square meters, the resulting pressure would be 8 million pascals, which can also be expressed as 8,000 kilopascals. In this scenario, the pressure is generated by the impact between two solid objects, namely the hammer and the nail. However, when it comes to fluids, which include both liquids and gases, pressure arises differently. The particles in a fluid are in constant motion and collide continuously with the surfaces they are in contact with. These frequent collisions exert forces that create pressure throughout the fluid. For example, in a sealed container filled with gas, the collisions of gas particles with the container walls result in pressure because each collision applies a force to the internal surface area of the container. The same principle applies to liquids. Imagine a beaker filled with water. The water particles collide with the sides and bottom of the beaker as well as with the air above the water's surface. These collisions lead to pressure being exerted in all directions, a phenomenon we refer to as fluid pressure, whether it occurs in a gas or a liquid. Regardless of whether the pressure originates from a solid, liquid, or gas, it is important to remember that only the component of the force that acts at a right angle or perpendicular to the surface actually contributes to the pressure. To better understand this, consider two particles colliding with a wall inside a container, both with the same amount of force. The first particle hits the wall at a perfect right angle, meaning the entire force is perpendicular and contributes fully to the pressure on the wall. On the other hand, if the second particle strikes at an angle, only a portion of its total force is perpendicular to the surface. When we break its force into vertical and horizontal components, we see that only the smaller perpendicular component is responsible for the resulting pressure. In practical terms, this is similar to the difference between hitting a wall head-on and brushing past it at an angle. To reinforce this concept, let us work through a quick problem. Suppose you are asked to calculate the perpendicular force exerted on an area of 0.5 square meters by a pressure of 60 kilopascals. Using the pressure formula in the form of a triangle, we know that force is equal to pressure multiplied by area. Since pressure must be in pascals and not kilopascals, we first convert 60 kilopascals to 60,000 pascals by multiplying by 1,000. We then multiply this by the given area, which is 0.5 square meters. The result is 30,000 newtons or 30 kilonewtons, which is our final answer. That brings us to the end of this video, and we hope the explanation was clear and helpful. If you found the content useful, please consider liking the video and subscribing to our channel. Otherwise, we look forward to seeing you in the next one.